Good morning, boys and girls, and welcome. This is Oceans Week, so I hope you all join in with us for the whole week. There's going to be a lot of fantastic ports cast to join in on. So I'm going to give you just a minute because I need you to get a piece of paper and some kind of coloring pencil or marker or just a plain old pencil, because we're going to do a little bit of drawing together later on in the program. Well, boys and girls, my name is Anita, and I am a state park interpreter here at this amazing park called San Elijo State Beach Campground. And today we're going to learn about jellies, but the jellies are out there. And this whole area of beach is a very special beach because it's part of a marine protected area. So let me show you from a map where we are today. We are in a little town called Cardiff by the Sea, and where you see that little blue dot is about where I'm standing. And this beach is also special because you can see that water flowing under that roadway there. And that's water coming from our watershed, entering the Pacific Ocean right here. So it's the last destination of the water from the watershed after a good rain. Well, boys and girls, marine means ocean. Protect. What does protect mean to you? Think about that for a second. If you wanted to protect something, if you're thinking keep safe, you're right. We want to keep all the algae and all the fish that live out here safe. An area means an area of space. So how many of you out there have boundaries at school? Places they let you play and places they don't want you to go. Well, if you do have boundaries at school, that's the school trying to keep you all safe. So I'm going to let you walk with me a little bit so you can see this whole beautiful marine protected area. So hang on with me. The camera might wiggle just a little bit for a minute. If we were to visit the most northern boundary of the MPA, we would walk this way on the beach. It's a little bit cloudy out here today. We would walk past Tower 16 and around that cliff that you see there. And we'd go 2 miles up the beach to another beach called Moonlight Beach. I'm going to come back south, our southernmost boundary. Can you all see those palm trees down there? That's about 1.5 miles from where I'm standing. And that's the southern boundary. But there's one more boundary. We have a boundary out here, out at sea, 3 whole miles straight out past the surfers that you see there. So with this big marine protected area, we're hoping to have a lot of different kinds of fish here. So if you and your family came to visit and you wanted to go out snorkeling, wouldn't it be a whole lot more fun to see more than just one kind of fish, right? And we want to have the little fish grow up to be big fish, adult fish. All right, boys and girls. So now you all know what an MPA is. And we're going to learn about our amazing jellies today. I brought Ruffles along today to help me teach you. So, boys and girls, in order to be a scientist, you have to be a really good observer. So I'm going to let you all be my junior biologists today, and I want you to do your best job at observing. I'm going to show you a video for 1 whole minute, and I want you to think about what you notice about these animals in the video. What do they make you wonder about? And do they remind you of anything maybe that you've seen before in your life? So here we go. Again, what do you notice? What do these jellies make you wonder about? And what do they remind you of? Boys and girls, these are moon jellies. And they are jellies that live right out here off our Southern California coastline. All right, boys and girls. So I'm wondering what you observed. So how many of you noticed that it moved kind of by pulsing? And maybe they made you wonder about something. I'm kind of wondering why they're so clear. And then what did they remind you guys of? To me, they look kind of like a flying saucer or the top of an umbrella. Okay, well, I hope you had fun being a junior biologist. So, while you were watching them, did they swim like a fish? You can give me a thumbs up or a thumbs down. What do you think, boys and girls? Did those jellies swim like that with a powerful tail? I don't think so, right? And then how many of you have ever seen a fish breathe? So when a fish breathes, it's going to open its mouth. Water's going to go into its mouth. Then the water crosses over these very delicate feathery like gills. And then the water comes out this side of the fish's face. And then there's a flap here that protects those soft gills. That flap's called an operculum. So when you look at a fish and you watch them breathe, you'll see these operculums moving like this. And those are helping to pull the water across the gills. But did our jellies breathe like that? Did you notice any gills in the video? I didn't. So what scientists want you to realize is even though sometimes we call these guys jellyfish, we just want you to be very knowledgeable that they're not related to the fish family. Jellies are related to other animals that sting, and they belong to a group called cnidarians. Good job, boys and girls. Well, I have a question for you now. And you can either agree with me or you can disagree with me. So what do you think? Do you think that there were animals roaming around this planet before humankind? You can turn and talk to your neighbor, have a little discussion. Do you think there was animals roaming around this planet before humankind? Okay, boys and girls, give us a thumbs up if you think there were animals roaming the planet before humans. All right, boys and girls, if you all agreed with me, what's the evidence? So I want you again to turn, talk to your neighbor and discuss, well, how do we know? Where's the evidence? How do we know animals were roaming this planet before us humans? So go ahead and take a minute and have that conversation. Okay, boys and girls, good job. So what evidence is there that proves there were animals roaming this planet a long time ago? How many of you came up with the word fossils? If you came up with the word fossils or bones, you are right. There are scientists called paleontologists, and they dig through the earth and they find bones from a long time ago. When they find those bones, they're able to put a little bit of chemicals on those bones, and those chemicals help to read how old the bone is. And then, of course, scientists, they like to chat with each other. So scientists from all over the world are comparing the ages of their bones. And what they've come up with is a timeline of life on Earth. So let's check out that timeline. Okay, boys and girls, so let's look at the far left on this timeline. Can you all see the number 500? Well, that stands for 500 million years ago. And the scientists gave that time a name. We call it the Cambrian period on Earth. And then if we start moving to the right on the screen, can everyone see the number 200 million years ago? That was a little more recently in time. And we call that era the Triassic period. And then let's keep moving to the right on that screen. Only 1.8 million years ago, we had the Quaternary period here on Earth. So I'm kind of wondering, who came first on this timeline? So I want you to turn and talk to your neighbors again. How many of you think maybe, was it the jellies? Was it the dinosaurs? Or was it humans? Go ahead and have that discussion with your partner. Good job, boys and girls. I wish I was there to watch you having these great discussions. So let's guess. How many of you, raise your hand, thought it was humans during the Cambrian period? All right, now, boys and girls, go ahead and raise your hand. How many of you thought it was the dinosaurs that came 500 million years ago to this planet? Good job. How many of you think it might have been those jellies? Raise your hand high. All right, boys and girls. Well, let's check out the answer together. Oh, it was the jellies. The jellies have been on our planet since 500 million years ago. That's crazy to think about. So I bet some of you out there recognize that word Triassic. So who do you think came next? You guessed it, the dinosaurs. And then, of course, lastly, some form of humankind. So that was pretty fun, right? All right, so we've dug up a lot of dinosaur bones over the years, but what about those jellies? How do we officially know that the jellies lived 500 million years ago? Can they leave a fossil? Go ahead and talk to your neighbors. Do jellies leave a fossil? Do jellies even have bones? What do you think? Okay, boys and girls, if you are thinking jellies don't have bones, you are right. They're very, very squishy animals, no bones about them. But how do they leave a fossil? Well, it's pretty interesting. How many of you have ever got to go to a beach, a nice sandy beach like this, and maybe you were able to make a sandcastle with your family? And to make a sandcastle, you're bringing buckets of water up to wet the sand, and you're pushing the sand around to mold that castle. And have you ever looked at your hand and had sand grains stuck to it? Well, you look at those grains and they seem pretty small, right? But in reality, what's happening is these waves that are out there, they're bringing sand to the beach where you and I like to play. But the heavier, bigger grains of sand end up staying here on the beach. And as the wave crashes and then the water retreats and goes back out to sea, as the water flows back out to sea, it's carrying very, very small grains of sand with it. So those grains of sand can drift quite a ways out to sea, and eventually they will sprinkle down to the sea floor. And so when we go out on oceanography expeditions and we collect bottom sediment from the ocean, what we're finding is we have siltstones, we have tiny mudstones, and did you know we even have clay on the sea floor? So when a jelly lives its long life out and then it falls to the sea floor gently, if it lands in just the right kind of sediment, it will leave a jelly stamp, and that will become its fossil. So I'm kind of wondering, what does that look like, boys and girls? How does a jelly leave a fossil? Well, let's look at a fossil that they found in the year 2007. Boys and girls, I'm going to put it up on the top right corner of your screen. There you go, boys and girls. That is what a jelly fossil looks like. And if you kind of look at it closely, you can see it's got these creases or striations that radiate out from the center to the edge. So pretty amazing stuff, right? All right, boys and girls. Well, over 500 million years, we've had 5 mass extinctions. And a mass extinction is when we lose all the animals in one species. So has anybody been being chased by dinosaurs out there lately? I hope not. So unfortunately, something happened to our planet to make the dinosaurs go away forever. So there's another mass extinction I can think of. How many of you have ever heard of the dodo bird? Raise your hand high. Very good, boys and girls. And there's one more I can think of. How many of you know of the woolly mammoth? That was an amazing animal that lived here long ago. So unfortunately, all of these three animals have suffered that mass extinction for one reason or another. But the jellies are still out there, boys and girls. They're still drifting around. So that tells me one thing. And I want to see if you can guess the word that I'm thinking of. So let me get my pen ready. What do you call it when an animal or a plant over a very long period of time can change its body part to better survive in its habitat? So there's a word for that. Can anybody guess what that word is? Go ahead, turn and talk to your neighbor. See if you can come up with that word together. I'm going to give everybody a hint. The word I'm thinking of starts with an A. Can you guess what that's called? So when animals and plants can change over time, something small maybe on their bodies, it helps them survive better in their habitat. And we call that adaptations. So that's what they're doing, boys and girls. They're adapting to their environment so they can live even longer on this planet. And that's what those jellies have done. So let's take a look together on all these amazing adaptations of the jelly. So this time, pull out your board and let's draw these amazing adaptations together. All right. So you can draw along with me and I'll label the parts to the jelly. So remember, what did you think that jelly looked like? I thought it looked like the top part of an umbrella. So I'm going to draw my jelly like this. And this top part, boys and girls, has a name. We call it the bell. Okay, and we already talked about the jelly not having any bones, but the bell needs to be supported. So what we find on the inside is the bell is 98% H2O. How many of you out there know what H2O stands for? You're right. H2O is a fancy way of writing water, the word water. All right, so the jelly's full of water. Its whole body is being supported. And now the jelly needs to breathe. But we know that jelly doesn't breathe the same way a fish breathes. It has a very unusual way to take a breath. So jellies have very, very thin skin. So what's happening is water is able to pass through that skin. And in the ocean, boys and girls, we have oxygen dissolved in the seawater. So as the seawater is entering the jelly's skin, it's able to breathe. So I wrote O2, which stands for oxygen. And we know it's coming inside the bell so our jelly friend can breathe. So I'm going to write our other new vocabulary word here. There we go. O2 stands for oxygen. Good job, you guys. Well, now I know my fish friend has nice big eyes, so it can search the oceans for its food and its habitat. But did you see any eyes on the jelly in the video? Well, do you think they have eyes like this? No, right? Unfortunately, jellies don't have well-developed eyes like you and I, but go ahead and put a dot here at the base of the bell. And boys and girls, that dot is called an eye spot. Okay, boys and girls, let's review what we were learning. We have oxygen coming into the skin. We have the bell, the top part of the jelly, and we know it's made of mostly water. And we just had added an eye spot. And I spelled that word over here for you. So what is an eye spot? Does it work like my eyes and your eyes? Well, boys and girls, we have very well-developed eyes. So jellies, they're not quite there yet with their eyes. So let's do a little experiment together to see what they experience in the water. So this is the closest I can get you to what an eye spot sees. So I'm going to do it first, and then I want you to try it. I'm going to close my eyelids, and I'm going to keep my eyelids closed for the whole experiment, okay? So I'm going to close my eyelids, and then I'm going to cover my eyes with my hand. And then I'm going to look up, because I'm outside, I'm going to look up at the sky. And then keeping my eyelids closed, I am going to take my hand away and back, nice and slowly, away and back, away and back. So go ahead, you guys try that out there. Close your eyes, cover your eyes gently with your hand, and then take your hand away and back very slowly. And I hope you have a bright light or a window that you're facing. It'll help. So what are you observing when you're doing this, boys and girls? So let's take a look at Ruffles. So if Ruffles was wearing his eye spot and Ruffles was able to turn his body over and kind of pulls his way down into the ocean, what do you think Ruffles' eye spot is observing? Do you think it's light or dark? So give me a thumbs up, boys and girls. How many of you think as Ruffles travels deeper in the ocean, it gets darker? You are right. So boys and girls, if Ruffles chooses to turn his body around and kind of pulls his way up near the surface of the water, remember the sun's rays are coming down to the surface of the water. The sun's rays don't penetrate too deeply, but as Ruffles comes near the surface, what is he going to observe? And if you are saying it's going to get brighter or it looks kind of orangey to you, you're right. So that's one way that the jellies are able to orient themselves in the ocean, which is pretty cool. Now, boys and girls, jellies are getting even more adaptations because there is a jelly out there that has more than one eye spot. Its name is Polyorchis, and Polyorchis has several eye spots on the base of its bell. Pretty fantastic, right? Now, our jelly is going to maybe need something extra in the bell. And do you think jellies can do math? Do you think jellies maybe have a brain? I don't know. Do you think they have a little brain? Well, the answer is no, no brain. But what they do wear, go ahead on your bell, you can put a little crisscross to remind you that all along their bell, they have a nerve net. All right, now our jelly is getting hungry. What body part is missing? What do you think we need to add so the jelly can capture its prey? Boys and girls, prey is the food that they're going to want to eat. So what do you think we need to add? If you are thinking the word tentacles, you are right. So go ahead and just put 2 tentacles on each side of your jelly. And I'm going to spell that word here for you. Okay, and that's what these are. Just like the word sounds, tentacles. And while you're doing that, I want you to add some dots to your tentacles. They don't have to be perfectly aligned. I just want you to remember that these little dots exist all along the tentacles. Now, each of those dots, boys and girls, I'm going to put it in purple. Each of these dots that are along the tentacle, if you could peek at them under a microscope and make them look bigger, under the microscope, you would see that each dot looks like a little capsule. And inside the capsule, there is like a little coily structure. And on the top of this capsule, there is a trigger hair. So just remember that these little units are all over the tentacles. And we're going to give them a name. It starts with a C, but the C is silent in this name. These are called cnidocytes. And cnidocyte. And cnidocytes are very important to help our jelly capture its food. Because if a fish should swim in by the jelly, let's put a fish in here. If a fish accidentally swam through and bumped into those tentacles, there's those trigger hairs on the cnidocytes. What do you think happened? If you are thinking that the fish got stung, you are right. Did it get stung just once? It doesn't look like it. It looks like it got stung many, many times. So what happened, boys and girls, is that cnidocyte now got triggered. And that cnidocyte on the inside, that coily structure now pops out. And it has a barb on the tip. And this coiled structure has a name. It's called nematocyst. Stay with me. These are some big words, but we're learning them together. So that nematocyst has this little barb on it. And on the tip of that barb, there is some what we call marine toxin. So I'm going to put some marine toxin on the tip of that barb, and I'm going to spell that here for you. Marine toxin. Okay, that's our last new word. So we know the fish got stung several times. All these nematocysts have entered the fish. The toxin is now inside the fish. And now our fish, the toxin is going to act on the fish's brain. Okay, so that's going to make our fish go to sleep. And now the jelly senses that it can eat its prey that it caught. So the jelly is going to eat this fish that's dangling at the base of its tentacles. So here's the bell on Ruffles. Here's the tentacles on Ruffles. And the fish has now accidentally caught himself in those tentacles. And once that toxin goes in, the fish is going to stay still and not fight anymore. So now, how does Ruffles get this heavy fish up under the bell to its mouth, which is under here? It must have one more amazing adaptation, right? So look closely at Ruffles, boys and girls. Do you see any other body part that could possibly help Ruffles get the food to his bell? If you're pointing at this stuff inside, you guys are right. I'm going to lift these tentacles out of the way so you can see it better. This is one of the most beautiful parts on our jelly friends. This part is called the oral arms. And the oral arms are kind of springy and thick, and they can help push the food up under the bell to the jelly's mouth. And he has a very simple gut, boys and girls, nothing real complicated when he eats his food. But that's how he brings the food to the mouth, with the oral arms. So let's go ahead and put our oral arms on our jelly. So they're nice and big and fat. So I'm gonna make some nice big fat oral arms here. And I might even color them in for you so you can see them better. And I'm going to write that word out here. Oral, boys and girls, means mouth and arms. So these are literally arms that go to the mouth. Okay, boys and girls, I'm dying to see all of your drawings. I hope that you've been able to follow along with me on our diagram here. So that's the amazing adaptations of our jellies. Now, let's look at some more adaptations, boys and girls. All right, do you think jellies come in all the same size? Okay, if we look at Ruffles here, he's probably about 8 inches if we measured from tip to the bell to the other side of the bell. 8 inches, less than a ruler, right? Well, let's check out some pretty amazing size jellies. Wow, this orangey colored jelly in the center of the screen, its name is lion's mane. And lion's mane's bell is over 7 feet across. So boys and girls, if I measured from fingertip all the way over to my other fingertip, that's probably only 5 feet across. So can you imagine how humongous this bell is? And then lion's mane's tentacles can travel back behind lion's mane back about 100 feet, maybe even a little more than 100 feet. So lion's mane loves cold, cold water, and lion's mane lives out here. Lion's mane lives out here and likes colder water, actually. So you can find lion's mane in Oregon, Washington, maybe parts of Canada. All right, now there's a very small jelly hiding on your screen. Can you find it? It's the jelly down in the left corner. So if you take a look at your pinky fingernail, that jelly is only about as big as our fingernails. And its name is irukandji. And irukandji is small but mighty. It doesn't live here. Irukandji likes very, very warm tropical water. It lives near Australia. It even lives on part of the huge Great Barrier Reef. Okay, but it may be small, but it's mighty. Irukandji has some very, very potent toxin. So some jellies are tiny, some jellies are huge. Let's look at another adaptation that jellies have. It's all about color, boys and girls. We're going to look at this. So color in the ocean is kind of interesting. Color, light, travels in wavelengths. So let's compare it to an ocean wave. So in the winter out here, the storms come from really close by, and the wind pushes on that water and it creates waves. And being that it's close by storm, it causes these waves to be very fast, and each wavelength is very, very close together. Okay, so if this is a wavelength of light, this light could travel really far underwater. Now, my favorite kind of wave is here in the summer, where the storms are really far away that are bringing us waves. And when the waves arrive, they arrive one at a time, and it takes a few more minutes for another wave to come, another few minutes for a wave to come. So this is a very, very slow wavelength of light. So if this light was underwater, it would only go so far. So some light can go far in the ocean, and some light can only go a little ways. So let's look at two kinds of light. And boys and girls, when animals make light, we have a name for it. It's called bioluminescence. It sounds like a Harry Potter spell, right? Bio just means living, and luminesce means to light up. So check out the bioluminescence on these two amazing jellies. The jelly on the left is called red belly comb jelly, and the jelly on the right is called spotted comb jelly. And red belly is giving off red light. Now, boys and girls, we talked about that red light doesn't go very far in the ocean. So when red belly drifts around having that red color, red belly is actually blending into its background. It's very, very dark down there. So what do we call it when an animal matches its background? You're right, camouflage. So red belly is a camouflage artist. Now let's look at spotted comb jelly on the right. Spotted comb jelly is putting out this beautiful blue-green light. And the wavelength of blue-green light gets to go really far through the oceans. So if I was a little innocent shrimp with my big eyes on its stalks, and I was drifting in the ocean and I saw these blue-green lights, I might get curious. So I might make my way over to that beautiful light, and then spotted comb jelly would be able to capture me. Okay, so spotted comb jelly is using its bioluminescence to attract food to come to it. So two different ways of using bioluminescence to get food. Pretty cool, right? Hey, boys and girls. Now, jellies. Sometimes us humans get stung by them. And around here, the sting is really less than a bee sting, and it lasts less than a bee sting. So it's not too harmful to us. So we shouldn't really worry about a jelly accidentally bumping into us. But out here, the jellies play an important role. They actually feed two of my favorite sea animals. Can you think of a cute sea animal that feeds on jellies? I hope you can guess what I'm thinking of. Let's take a look at these two cuties. You guessed it, sea turtles. This turtle is a leatherback sea turtle. And this is one of the sea turtles that can travel thousands of miles through the ocean just because they're hunting for jellies. And then its friend over here on the right, that is kind of a funny looking fish, but they're adorable when they're babies. You see them just swimming around like this. They have a cute little mouth, kind of like the hose on a vacuum cleaner, and they can just slurp in jellies. So these two guys, they need the jellies to be out there so they can eat. But, sometimes us humans, sometimes we leave things laying around that could harm our ocean friends. Can you think of something us humans leave laying around, even on the land, and it makes its way out to the ocean? If you were thinking plastic bag, you are correct. Any kind of plastic is terrible for the oceans, boys and girls. But let's take a look. I have a friend, Miss Erica, and by the way, it's Miss Erica's birthday today during Oceans Week. Let's take a look at Miss Erica. She is scuba diving here. And Miss Erica found two things drifting in the ocean. So she picked them up. But what does that thing in this hand look like to you? I'm going to take a closer look myself. Is it a jelly? Is it a plastic bag? If you're thinking it's a plastic bag, you are correct, boys and girls. Now, let's take a look at who's headed towards that plastic bag. Can you guys see a sea turtle in the background anywhere? Look behind Erica's other hand. Can you see a dome shape? There is a dome shape right there in that red circle that I drew. And that's a sea turtle that was headed for that plastic bag. And I think Miss Erica saved the day this time from that jelly, from that turtle getting a hold of that jelly. So boys and girls, when these plastics get into our animals' friends, especially those plastic bags, if this was my edge of my stomach, that plastic bag will line the edge of the stomach. And as the animal eats more food, the more food cannot be absorbed by the stomach lining because that plastic bag is there. And essentially the animal will starve. And it also makes them very, very ill, right? So What could you and I do every day to help our mola mola and our sea turtle friends? Can you think of something that you would do to help them out? I bet you have lots of great ideas out there. But yes, I know you've learned the 3 R's: reuse, reduce, recycle. That's going to help our earth tremendously. And there's another phrase I want you all to learn. When we walk around and we do our park surveys, we think to ourselves, take 3 for the sea. So if we all picked up 3 pieces of trash anywhere we are, the school grounds, the park, the beach, we're going to keep 3 pieces of trash to getting into the oceans and harming our ocean friends. So good job, you guys. I'm so happy that you are out there helping the planet. This is Earth Weeks after all. So I hope you all can do your best all the time to help save the animals in our planet from harm. All right, boys and girls. Well, I want to say thank you very much for joining me here today at San Elijo State Beach. And I hope you enjoyed the rest of your Oceans Week. Good work today, boys and girls. Have a good day.